Good afternoon, my chemistry minions. Lecture number 3. One more to go after this. Today we're going to look at transmutation, specifically in nuclear chemistry, and even more specifically, artificial transmutation, the kind that us humans get to do. Distinguish between nuclear fission and fusion. Remember, fusion sounds like fuse. That's putting two things together. Describe relative amounts of energy produced, advantages and disadvantages. And then we got to get into Einstein's E equals mc squared to nuclear transmutation and mass effect. Okay? How are fusion and fission different and similar? Well, fusion is breaking apart while fusion is fusing together while fission is breaking apart. Okay? That's basically really all we really need to do. And here is a little bit of what's going on. If I look at fusion, I'm going to take this and this, ram them in together, and come out with something that is the commonality of them with a neutron coming off. And this piece is bigger than this piece and this piece. Where fission is bombard this with a small particle that blasts right through it and breaks them apart along with some more photons. Okay? So fission is breaking apart where fusion is putting together. So artificial transmutation, I'm going to bombard the nuclei with high energy particles such as a neutron or an alpha particle. And then fission specifically is splitting. A larger particles are split into two smaller particles. And here is an example. I'm going to take uranium with a neutron. The neutron's going to come in and hit that thing. The neutron's going to come through, and it's going to split half of this off into Ba, half, it's roughly half, right, 56 and 36, and I'm going to get another neutron each, okay? Note, the energy is also produced in the above reaction. So basically, I'm going to add in that nutrient and split it, fission. Okay, disadvantage of fission, thermal pollution is a byproduct. It does produce a lot of energy. Okay, which if I use that energy to say heat water, then I can boil, I can get a turbine to move as opposed to burning coal to get that turbine to move. So in that regard, it could be a beneficial thing. Okay, nuclear fusion, let me take a lighter nuclei and combine them together to produce something heavier. Okay, so in here the deuterium H2 and a tritium H3 come together, produces a helium and a neutron. Okay, I'm going to fuse those two things together, and there is a byproduct, and then there's some energy. This is what's going on in the sun, by the way. This is how the sun gets to where it's at. And each of the atoms has a particular wavelength of light that it gives off. So if I run the light that comes from a star through a spectrometer, I can break apart the wavelengths of light and come to what particular elements it's at. And as these things combined and combined and combined, the star continues to burn. And once I get into the iron stage, or nickel, once I get to nickel, which is element number 28. Once I get to nickel, it's about too heavy for it to continue. I'm not sure exactly where our sun is, but our sun is a star, and by the time it fuses into nickel, it will burn out. And that is when the sun will cease to exist as a star as we know it, and that's when the planet is going to have some major challenges staying warm. All right, here's some other examples. Adding some things together and what I'm going to give off. Okay, advantages of fusion. Lots of energy is given off, no waste. You might get a part 2 question like this on the Regents exam. The example, the sun uses fusion, so there's a good one. Okay, normal form of fusion is definitely the sun. So I wouldn't necessarily call that artificial transmutation. That is a form of transmutation that happens naturally. Disadvantages. I need to overcome the need for extreme heat. You need to develop materials strong enough to withstand that heat. We generally use some sort of ceramics. difficult to contain the nuclei into a small enough area, hard to control the reaction. It's not something that I can just set and go. Okay. Notice energy is produced as a product in both fusion and fission reactions, but where does the energy come from? The total mass of the products is less than the original mass of the reactants, which leads to this mass defect. Small amount of mass involved in reactions is lost and is converted into energy. This involves Einstein's famous formula, E equals mc squared. Energy is the mass times the speed of light. Okay? We're all done with this video. This one should be a little quicker. We got one more to go, and videos for the year are done unless I decide to make some review videos for you. So we can now distinguish between fission and fusion. Fission is breaking apart. Fusion is binding together. Describe the relative amounts of energy produced by each and some advantages and disadvantages. We can now do practice page 4 through 8, do nuclear prep number 2 and quiz number 2, and we are almost done with the unit. See you guys tomorrow in class.